So this video is to review lines. So if you think back to Algebra 1, when you first started studying lines, or when you probably first started studying lines, you would have probably started by being given an equation, and then you would have made a t-chart where you would have chosen values to plug in for x, and then you find the y that goes along with that x. And then you would have been introduced to the different forms of the equation of a line. And first, you probably would have started with standard form, which is not my favorite form of the equation of a line. It's just not so useful in telling us characteristics about the line. And then you probably would have learned slope-intercept form, y equals mx plus b. This tends to be the form that students remember the best, just because the formula is, for whatever reason, the easiest to remember. And then there is the best form of the equation of a line, point-slope form. So we're going to go through each of these forms and how to graph them. And we'll start in the same order that you did way back when in Algebra 1 with standard form. So standard form is ax plus by equals to c, where a, b, and c are actually just integers, and a is supposed to be a positive integer if you're thinking like strict standard form. So to graph a line, when you're given standard form, it's usually the most efficient to find the x and y intercepts. So to find the x-intercept, you're going to let y equal to 0 and then solve for x. And remember, an x-intercept, we're representing a point. So you need to write the ordered pair that represents the point, not just x equals to 5 or whatever x is. Okay, so the reason that we substitute y in for x, the reason we substitute 0 in for y is because when we're solving for the x-intercept, we're solving for where the line will cross the x-axis. So remember, the horizontal axis is the x-axis and the vertical axis is the y-axis. Any point that lies on the x-axis is going to have a y-coordinate of 0. Then, for finding the y-intercept, you're solving for where the line will cross the y-axis, and that's the vertical axis, where every x-coordinate for any point on the y-axis will be 0. So, in this first example, let's go ahead and find the x-intercept first. So we know that the y-coordinate is 0. I'm going to substitute 0 in for y in the equation. So when we simplify the left-hand side, we get 2x equals to 4, then divide by 2 on each side, and we get x equals to 2. So now that we have the ordered pair that represents the x-intercept, we can go ahead and graph that. And then find the y-intercept, where I know the x-coordinate will be 0. So I substitute 0 in for x. And 2 times 0 is just 0. If we divide each side of the equation by -4, we'll get y is equal to -1. So we can go ahead and plot that point. Now, 2 points define a line. So there is a unique line that will pass through any 2 points. But what if we wanted to extend this line? So right now I could draw the line, and it would be the line that this equation, 2x minus 4y equals to 4, represents. But if we want to extend the line, we could always use the slope. So the slope of the line is a ratio that describes the steepness of the line. And if you think back to Algebra 1 or whenever you last studied lines, slope, remember, is rise over run. We read graphs from left to right, just like a book. So this first point here that looks like it's at 0, -1, to get to the next point, which is at 2, 0, I would have to go up 1, so my rise would be 1, and then to the right 2, so my run would be 2. So the slope of this line appears to be m, right? We use m to represent the slope, is 1 over 2, or 1/2. So now we can use the slope to extend the line. Okay, so going to the right, I would go up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. And then to go to the left towards the negatives, I would do the opposite. I would go down 1, left 2. Down 1, left 2. Because that would be like a rise of -1 and then a run of -2. So those negatives would cancel out in our rise over run ratio. And then for graphing from standard form in an equation that's in standard form, you could always just make a t-chart and pick values for x to find the y values for, and then plot points. But the intercepts are just too easy points to find. Okay, so we just talked about the slope of a line being rise over run, which is equivalent to the change in y over the change in x. So that can be represented as delta y over delta x. That triangle here is read as delta, right? The Greek letter delta. So delta y over delta x. And the formula, which everyone seems to remember, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And it's just important to make sure, if you have 2 points and you want to find the slope of the line, you can use this formula. And it doesn't matter which point is point 1 or point 2. It just matters that you're consistent with which one you choose to be point 1 and which one you choose to be point 2. So in the formula, the ordered pairs should line up vertically so that you don't have any sign errors. Okay, so the second form of the equation of a line that you probably learned about was slope-intercept form. And it's in the name what the equation it tells you about the line, the characteristics of the line that the equation tells you. So it tells you the slope, and then it also tells you the y-intercept. And think about it from standard form. If we were to find the y-intercept, we would set y equal to 0. Not y. We would set x equal to 0. Oops. And then solve for y. Well, if we make x equal to 0 for an equation that's in slope-intercept form, we just end up with y equals to b. So that's why the y-intercept ends up just being 0, b, whatever b is. Okay, and then the slope is m. So we'll graph. We want to start with a point and then use our slope to help us extend the graph. So start by identifying the y-intercept, which, let's switch colors. So the y-intercept for this next example is 0, 5. So I'll go ahead and graph that. And then the slope, it looks like, is -1/3. So this is a negative slope. In our previous example, the line had a positive slope. I like to assign the positive or the negative to the numerator so that the rise is either positive or negative. So I start at my point. Because this is a negative slope, I'm going to say, okay, the rise is -1. So I would go down 1 and then right 3 to get to my next point. So down 1, right 3, down 1, right 3. And then I would do the opposite going towards the negative. So I would go up 1, left 3, up 1, left 3. Okay, point slope form is my favorite form of the equation of line. I think it And that's because I think it's the most efficient, and it'll definitely help you with saving time next year. Or not next year, sorry. I was thinking this is pre-calc honors. It'll help us save time when we start studying derivatives and we need to write the equation of the tangent line to the curve. Okay, so it'll help us save time. So point slope form is also, it's in the name, what we're able to easily identify about the line. So we can identify a point, okay, not necessarily the y-intercept, but we can identify a point that the line passes through, and then also the slope. And in identifying the point, you need to be careful. So notice that x minus x sub 1, okay, so x sub 1 is the x coordinate for the point that you're able to identify. So for example, if this said x minus 2, that means that 2 would be, so if this said x minus 2, 2 would be the x coordinate for the point. But if this said, say, x plus 2, which is the same as x minus negative 2, that means that the x coordinate would be negative 2. So it's the opposite sign. You have to be careful with that. And then the same thing goes for the y coordinate. So if we had y minus 7, then 7 would be the y coordinate for the point. But if this were y plus 7, then negative 7 would be the y coordinate for the point. And so point slope form is, for whatever reason, students seem to have trouble remembering point slope form, but it's derived from the slope formula, which I think that students tend to remember when they learn it. So slope formula remembers m equals to the change in, not x, sorry, it's been a long day, so the change in y over the change in x. Well, if we made this y sub 2 and x sub 2 just the variables x and y, so still slope formula, but y minus y sub 1 over x minus x sub 1, and then multiplied each side of this equation, right? This is an equation, there's an equal sign, times x minus x sub 1. Okay, we would have x minus x sub 1 times m equals to y minus y sub 1. So this looks pretty darn close to point slope form, but we can just use a couple properties of real numbers to help us rewrite this so that it actually looks like point slope form up here. So by the commutative property of multiplication, which says a times b is equal to b times a, we'll be able to switch these factors here. And then by the symmetric property of equality, we'll be able to flip-flop the left and right-hand side so that we get y minus y sub 1 equals to m times x, the quantity x minus x sub 1. And then we have point slope form. Okay, so looking at this equation, the point that we're able to identify is 1 comma negative 3. So I can start by graphing that point, and then I see that the slope is 3/4. So I'll use the slope to find other points, additional points. So I'll go up 3, right 4, up 3, right 4, okay, and then down 3, left 4, down 3, left 4. Now, every line has infinitely many points. So we just graphed the line from this given equation. But because there's infinitely many points, that lie on the line, that means there's infinitely many equations in point-slope form that can represent the same line. Like if we wanted to write an equation using, say, this point, right? That's 9, 3. So the equation that would represent the exact same line, but using this point, would be y minus 3 equals to 3/4 times x minus 9. And we would be able to prove algebraically that these two equations represent the same line just by changing them to slope-intercept form and showing that they have the same slope and y-intercept. The equations have the same slope and y-intercept. And you can do that just by distributing the 3/4 in and then adding or subtracting the constant over, combining like terms. So just changing it to slope-intercept form. So you can easily go from one form of an equation to another using algebra. So if we start with this equation that's in standard form, we can easily change it to slope-intercept form by solving for y. So we would subtract 2x from each side of the equation first, and then divide by -5. Okay, and then we are in slope-intercept form. Okay. Now there are a couple approaches you could take to changing to point-slope form. So, like if we were to add 2 to each side, or recognize that 0, -2 is the y-intercept, which is a point that you could then plug into point-slope form. But if we were to also think about using properties of equality here, that would be y plus 2 equals to 2/5 x, where I could also rewrite the right-hand side as 2/5 times, in parentheses, x minus 0. Okay, and that looks more like point-slope form. The other way that you could have changed slope-intercept form into point-slope form is to rewrite the left-hand side as y minus 0 equals, and then factor out the 2/5 from the difference here. So when we factor out 2/5, we would have 2/5 times x minus 5. Both are point-slope form. Both represent the same exact line. Okay, so if we want to write the equation of the line that passes through these 2 points, there are different approaches you can use, but I suggest we already have 2 points. We can just choose one of the points, but because we have points available, we can just find the slope by using slope formula and then write our equation in point-slope form. So we get -4/7 as the slope. And then if I use this first point, I would do y minus 1 equals -4/7 times the quantity x plus 2. Or if I wanted to use the second point, I could do y plus 3 equals to -4/7 times x minus 5. So both equations represent the line that passes through those 2 points. If I'm asking you a question like this on homework or a homework quiz or something, you just need to give me one equation. I do not need both. All right, so horizontal lines I know you guys are familiar with, so I'm just going to draw a horizontal line. And the equation of all horizontal lines can be written in the form y equals to some constant. So like the equation of this line would be y equals to equals to 6. And that's because every point that lies on this line, what is that, 7,6, has a y coordinate of 6. It doesn't matter what x is, y is always equal to 6. now for slope, so I have 2 points here. If I were to try and use slope formula to find the slope of this line, so change in y over change in x, I would get 0 over 7, which is just 0. And you can see, just looking at what a horizontal line looks like, the change in the y values between any 2 points is going to be 0. Therefore, the slope of all horizontal lines is 0. Okay. You guys know what a vertical line is. Let me draw one though. Okay, so vertical lines, the equation for a vertical line is x equals to a constant. This one would be x equals to -3. Similar reasoning. The x is going to be constant. Like every point that lies on this line will have an x coordinate of -3, while the y value will change. And if we go and try and use slope formula to find the slope of this line, we would get, for these 2 points, we would get -4 over 0, which remember 0 can't be in the denominator, is undefined. So the slope of all vertical lines is undefined. Okay, parallel lines have the same slope and different y-intercepts. If they have the same slope and the same y-intercepts, then the equations represent the same lines, or the same line. So if I graph these 2 lines, which are parallel because y equals 2x has a y-intercept of 0 and a slope of 2, and y equals 2x minus 1 has a slope of 2 but a y-intercept of -1. So the different y-intercepts for the same slope. These 2 lines are parallel. And if we graph them, it reminds us that parallel lines do not intersect. They have no points in common. And if you are graphing more than one line in the same XY plane, please make sure to label. That goes for the rest of the year, actually. Like if you have 2 equations graphed in the same XY plane, make sure you are labeling. All right, perpendicular lines have slopes that are opposite reciprocals of each other. Opposite means like opposite sign, positive or negative. So like the opposite reciprocal of 4 would be -1/4. Or the opposite reciprocal of -7 would be +1/7. Okay, so these 2 equations represent lines that are perpendicular to each other because the slope of the first line is 2, and then the slope of the second line is -1/2, and those are opposite reciprocals of each other. So if I graph again, y equals to 2x. And then graph the second line, so the point that I'm able to identify from this equation, it looks like is 3, 1. And then the slope of -1/2, I go down 1, right 2, down 1, right 2. label. Okay, and then we can see here perpendicular lines intersect at a right angle, a 90-degree angle. Okay, so we're in a math class, and when we are looking at applications of calculus and whatever it is that we're studying, we want to look at an application to the real world, we're often going to be trying to model situations with equations or functions. So in this case, so for modeling with linear equations, we're going to want to try and come up with an equation that can model a situation to help us solve for unknown quantities and also make predictions. So in this example, a frozen yogurt shop charges 10 cents for the cup and 65 cents per ounce of frozen yogurt you put in the cup. What's the equation? What is an equation that can model the total cost of your frozen yogurt purchase as a function of the number of ounces you add to the cup? Okay, well, the cup is going to cost 10 cents no matter what, but the number of ounces of frozen yogurt that you add to the cup is going to vary, and that's going to, the price is going to depend on that amount. Okay, so if I let X equal the number of ounces of froyo that you add to the cup, and then Y be the total cost of the froyo in dollars, okay, we'll have Y equals to 0.65X plus 0.10. Please make sure you are defining your variables when you have a word problem and you're using units in defining your variables. Okay, so we want to know how much would it cost if there are 3 ounces of frozen yogurt in your cup. Well, we're given the amount of froyo and we want to solve for the total cost, which would be Y. So I'm going to substitute 3 in for X, and when I simplify that, I'll get Y equals to $2.05. So for word problems, you should be summarizing your solution in a full sentence as well. So like I could say 3 ounces of froyo cost $2.05. Okay, we also want to use our equation here to find out how many ounces of frozen yogurt did you purchase if you spent $5.42. So I am given the total cost here, and I need to solve for the number of ounces of froyo. Subtracting 0.1 from each side. Okay, so this is actually this ratio is the exact value of the number of ounces, but if you pop this into your calculator, I believe you get 8.185, and that's ounces. So if you spent $5.42, then you purchased approximately 8.185 ounces of froyo.